Welcome to One Off Coder. I'm Dr. G Vang, and today I'm going to talk about Java streams. What are streams in Java? Let's not get into technicalities. Streams are simply what the name implies: flowing data. Processing streams involves a functional and fluent way of coding. By functional, I mean the style of coding that is declarative. By declarative coding, I mean coding that describes what you are doing. This is in contrast to procedural coding, which describes how you are doing something. So declarative emphasizes what, and procedural emphasizes how. By fluent coding, I mean the coding style that enables you to chain together operations or transformations. In many programming languages, fluent programming is visually apparent by invoking functions chained after one another using dot notation. Another key concept is a functional interface. What is a functional interface? Don't overthink it. A functional interface is simply an interface with one method. Remember, an interface is just a contract. A functional interface is thus a contract specifying one method. The last key concept you should be familiar with is a lambda expression. Lambda expressions are simply a way to write functions. You can use lambda expressions to implement a functional interface. In this video, I'll show some cool ways to interact with integer streams. Let's motivate streams with a simple example of printing an array of integers. Here, we have an integer array. These values represent some made-up age values. If I ask you to print each element from this array, the first thing you might want to do is to write a for loop. The for loop is complicated. There's 4 parts to a for loop. First, we have an initialization part, then a termination condition part. And the change must also be present to make sure that the loop terminates. The body is the last component of a for loop. It takes a lot to set up iteration over an array using a for loop. There's the for each loop syntax that we can use to iterate over the integer array. Moving over the elements is greatly simplified. The for each loop is said to be concise in its expression. Reading it sounds like natural language. For each age in the list of ages, print the age. Note here we don't have that many moving parts as in a regular for loop. There's no initialization, termination, or change to set up. If all we wanted to do was to print each element from the integer array, we can convert the array to a stream and process the stream to print each element. To convert an array to a stream, we use the ArrayStreams function. Once we have a stream, we can apply transformation and action operations against a stream of data. This is a nuanced understanding. Some operations on a stream return another stream. These are called transformations. Some operations on streams return an actual value or a collection. These are called actions. We'll see plenty of examples. For now, after I convert the integer array to a stream, I apply the forEach function to the stream. The forEach function allows me to write a lambda expression to define what I want to do with each element. Here, I simply print the age. We don't have to use a lambda expression with the forEach function. Here, I know that the forEach function requires a functional interface called IntegerConsumer. The signature of the functional method of this functional interface is void accept int value. This functional interface, IntegerConsumer or IntegerConsumer, simply defines that an integer will be the input and there is also no output. Here, I define an instance of IntegerConsumer using a lambda expression. The functional interface instance is called PrintAge. When I invoke the forEach method, I simply pass in this functional interface instance. Implementing functional interfaces with lambda expressions is quite fun. Here, I test out printing each age in 2 different ways. With the PrintAge instance, I simply print out the age. With the PrintAge statement instance, I print a text to make sure that it's more clear I'm printing an age value. You'll notice I create 2 new streams while I'm testing out the 2 different IntegerConsumers. Once you finish consuming a stream, it reaches the end and you cannot try to consume it again. I'll emphasize the problem of trying to consume an already consumed stream here. I'll create one integer stream instance called stream. I then attempt to invoke forEach twice on this stream separately. The second forEach will result in an illegal state exception. You can compose a functional interface of other functional interfaces. Here, I have 2 IntegerConsumers, print current age and print next age. Note that these 2 implementations do not use systemoutPrintLine, but rather systemoutPrint. A third IntegerConsumer is composed of these 2 called PrintAge. It simply calls print current age followed by a print statement, print next age followed by a system out print line. Notice when I use the print current age and print next age instances, I invoke the accept function. Once you have a stream, you can do some amazing things to process the stream elements. Here, I show how to apply a map function to the stream. At a high level, map takes in an element and returns another element. Map is said to be a transformation operation. For streams, the map function takes in the int urinary operator functional interface. By definition, the functional method of this functional interface takes in an integer and returns one. I can inline an implementation of this functional interface using a lambda expression. Here, I simply add 1 to the age and return that as the result. I end with printing the resulting elements, which should be the original ages plus 1. In the for each method, I like to point out the use of the method reference operator, which is the double colons. This operator will point to a method that can be used as the functional interface implementation. Here, I reference the printLine function on the systemout object. The method reference operator makes the code much more concise if we just wanted to simply print the elements. Let's reinforce the idea of mapping. Here I apply two map operations. The first map adds 1 to the age, and the second map takes the previous result and squares it. It might be beneficial at times to decompose complex operation into multiple map steps for diagnostic and debugging purposes. Filtering a stream is accomplished with the filter function. The filter function takes in an int predicate, whose functional method takes in an integer and returns a boolean. Here, after adding 1 to the age, I'm filtering out the results that are odd. You should only see 20 being printed. You don't have to issue a filter after a map. You can also filter and then map. In this example, we filter out for even ages, and then we apply a map by adding 1 to the age. Finally, we print out each result. There are 3 functional interfaces at play here: int predicate, int urinary operator, and IntegerConsumer. You should see 19, 23, 35, and 45 printed out. You can sort the stream by calling the sorted function. This function doesn't require any inputs. You should see 19, 20, 23, 35, and 45 printed out. If you want to keep only distinct elements, call the distinct function. Notice how I've duplicated 18 and 22 in the integer array. You should see 19, 20, 23, 35, and 45 printed out after applying the distinct function. It's nice to aggregate over streams. The sum function will total up the numbers in an integer stream. Earlier, I said you can apply transformations and actions. Transformation results in a stream, and actions result in a value or a collection. Sum is an action. It'll return you a result as opposed to another stream. Another way to apply aggregations is with the reduce function. The reduce function requires the int binary operator functional interface. Here, for any two integers, a and b, I simply add them and return the result. Notice that the return type for int binary operator is an optional int. That is why I have to invoke the getAsInt function. The total printed out should be 142 for both approaches. Averaging is a useful summary statistics. The average functions can be applied to an integer stream. Average returns an optional double, and so I have to call getAsDouble. The result printed should be 28.4. I can limit how many elements in a stream to process. The limit function requires an integer to specify how many elements to process from the start. After this limit is reached, the stream will stop processing. Since we typically do not know how many elements will arrive in a stream, we can enter any positive integer. If the integer exceeds the number of elements in the stream, that will be okay. You should only see 18, 22, and 19 printed. The skip function is the complement to limit. The skip function will force skipping over the specified number of elements. Here, I want to skip over the first 3 elements. What should get printed are the numbers 34 and 44. We can also convert an integer stream to a double stream. To do so, call the asDoubleStream function. I want to have some fun, and so after converting the integer stream to a double stream, I add pi to each age. Peeking is a way to see the intermediary results of your transformation. If you have a complicated data transformation pipeline, you might want to peek at each steps to log what's going on. Based on the previous example, I want to convert the integer stream to a double stream, and then add pi to each age. I can peek at the original stream, the double stream, and also the transformation of adding pi. Notice I'll have to call toArray at the end. If I didn't do that, then I would see nothing from the peek functions. That's because all these operations are transformations. The toArray method is an action that will trigger the transformations to occur. You can issue parallel operations on a stream by calling the parallel function. Issuing parallel operations on a stream makes sense when you have an enormous amount of data flowing through the stream. The processing of the integer array of ages is the same as before, except we call parallel. To get the point across, I create an integer array of 10,000 integers. I use the endStreamRange function, which creates a stream of numbers from 0 to 10,000. On the stream of sequential numbers, I issue a map where I generate a random number between 0 and 100. We're only focused on processing streams here at the moment, but in case you're wondering about other ways to create a stream, try looking into the intStream class. Because we're sampling or generating a lot of integers between 0 and 100, the average should be about 50. We can collect a stream by calling the collect function. The collect function is an action and will trigger the transformation pipeline to occur. The required argument to collect is a collector instance. The collectors class has a number of useful ways to create collector instances. In this example, I want to join all numbers into a single string delimited by a comma. As such, I call the collectors joining function. Before I invoke collect, however, I convert all integers to their string representation using the map-to-object function. In general, creating a single delimited string is not trivial or easy in Java. With streams and the collect function, this operation is now easier given we continue the practice of using streams. I can also transform a stream into a map. Here, I want to create a map where the key is the age and the corresponding value is a boolean indicating if that age is even, true, or not, false. This time, before I call collect, I call box to convert my integers from raw integers to object ones. In the collect function, I use the collectors to map function, which has two lambda expressions, one to create the key and one to create the value. Interestingly, once I have the map instance, I can turn the set of key value pairs into a stream. The key value pairs are called the entry set. Once I get the entry set as a stream, I invoke for each on each entry and print out the key and value. I'm spicing things up a bit here. In the last example, I created a map where the key is an integer and the value is a boolean. Here, the key will be a string and the value will be a list of integers. The key will either be a string literal, even, or odd. And the list will be a list of numbers corresponding to these keys. The list corresponding to the key even will contain only even numbers, and the list corresponding to the key odd will contain only odd numbers. Again, I call box to change the raw or primitive integer to object ones. In the collect method, I use the collectors grouping by function to map each element to a key and force the group of an element to a list. The even numbers should be 18, 22, 34, and 44. The odd ones should only be 19. Thanks for watching. We'd love to hear your feedback to create better and new content. Please contact us by going to our website at https://oneoffcoder.com. Until next time, happy coding and happy learning.